Hey guys, this is JP Mom from Planning Seeds Tutoring. In this video, we're going to be talking about acceleration and velocity. Let's start off with velocity actually before we go into acceleration. So velocity just refers to the change in, actually I'm going to write down, the change in displacement over the change in time. All in all, how far have you gone over this much time? And remember, displacement, this is a vector. This is a vector quantity, which means that not only does it have like a value in terms of like a magnitude, but it also has, oops, that's supposed to be displacement, not displacement. Displacement. Anyway, all that means is that it has both a direction and a magnitude, and not just like a certain value in terms of display, in terms of values. In general, especially in like a general kind of problem, you usually just go around with like a left and right displacement. Sometimes you're also going to be commonly working around with like a vertical and horizontal component and stuff, and so like you might be going like 30 degrees up in one direction. And that's going to be your displacement. That's going to be like the direction of your displacement at least. And then how far it went is going to be the other portion, the magnitude. Anyway, it's going to be the change in displacement, which I generally denote as the delta D vector over delta T. This capital letter delta, this triangle looking shape, all that refers to is just this portion, the change in, it just means change in. That's all that means. So this, and by the way, like in general, like a future math class and stuff, people don't like to use D. They like to use D for some other stuff, like specific like derivatives and stuff. So generally, people can also write this down as like change in X over time, or maybe even change in S over time. Depends on who's writing it. But overall, all velocity is, it's just how far you've gone over a certain amount of period of time. Now, again, since this direction right here, or this distance right here has, or the displacement, it's a vector. So it has a direction component to it. As a result, the velocity vector, velocity is a vector as well. This is also going to be a vector. And that means that the velocity also has a particular direction. So it's in whatever direction the displacement was in, that's the direction that the velocity is going to be in as well. So change in time, or change in the distance displacement over time, change in time. Speed, on the other hand, is a scalar value. It only has a magnitude. Speed would be without this arrow kind of like symbol. People sometimes use just like an arrow. I'm kind of a little lazy, I guess. I just write down the top hat. But both are correct notations. V just refers to speed, which is a little different from velocity. Velocity, remember, is a vector. Speed is just a scalar. So this only has a magnitude-based value. It only has the number value. It doesn't have like the angle or like whether or not it's positive, negative, or any like direction attached to it. So speed is going to be whatever the distance was over time, which is X over T. Very, very similar. You can also say it's delta T stuff over time, but very similar. It's just the main difference being this hat right here indicates that it's, this right here is a scalar, while the other is a vector. All right, so now why is this important? Well, velocities, they tell you pretty much in which direction. Not only does it tell you which direction something is moving, it also tells you how fast that object is moving. That's pretty much the whole objective of any kind of velocity. It just tells you how fast an object is moving. Now, acceleration, on the other hand, acceleration we also represent with a vector. Acceleration is also a vector, and this is going to be the change in velocity over the change in time. So all this means is acceleration just refers to how much has the velocity changed over some period of time. By the way, when we talk about this delta symbol, you don't necessarily need to write it down as the delta symbol per se. Another way we tend to use it is, for example, for velocity, we also just write this down as the final velocity, or final displacement, wherever that was, however far it ended off, versus the initial location, wherever that was, over the final time, however long it took, minus the initial time. When did you start counting? And that's what delta x over delta t just means. So in the same way, acceleration, the change in acceleration would be pretty much identical. So it would still be divided by change in time. But up top, you would have change in velocity, which means you have a final velocity and initial velocity, which gets you the average acceleration. Okay, so acceleration, velocity, and displacement are all vectors. Distance and speed, those are both scalars. And the importance about all of this is that, for example, let's say that you're talking about a car. Teslas are pretty popular these days, so let's just talk about maybe like a Tesla Roadster. I think you might have heard of like acceleration in terms of people talking about the 0 to 60 of a car is some amount of time. I think for the Tesla Roadster, it's about 2 seconds. I think it's like 1.9 seconds, but just for the sake of like simplicity, we're just going to approximate to about 2 seconds. 0 to 60 meaning how fast, how long does it take for this car to reach 60 miles per hour from 0. This is 60 miles per hour, by the way. From 0 miles per hour. Well, the answer here is 2 seconds. Well, what does that mean? Well, that 60 miles per hour and 0 miles per hour are both indications of speed, and technically also in terms of velocity as well. If you know which direction the car is moving, then you also know how fast it's moving, then that means you know what the velocity is. So let's say that this car right here is moving to the right at 60 miles, and you're trying to figure out, about this acceleration. How fast is it moving in terms of maybe like miles per second squared or something? Well, you have 60 miles was the final velocity. Miles per hour was the final velocity. The initial velocity was 0 miles per hour. And both of those are positive because they're going to the right. So this is VF minus VI. That's what we did here. And this is being divided by TF minus TI. Well, we started at time 0. That's when we started counting. And it said that we only counted for 2 seconds. That's just being divided by 2. So in total, this comes out to being 60 miles per hour over a matter of 2 seconds, which comes out to being 30 miles per hour per second, which intuitively just means over a span of 1 second, the car is going 30 miles per hour faster than it was earlier. Which, I mean, assuming, of course, that this is like a constant acceleration, which it is actually not, so it doesn't exactly work out that way, but still. The idea is intuitively, this is kind of how it works out. So what is this in terms of like maybe like miles per second squared or something. Well, miles per hour per second. I'm just going to write down S for seconds. Well, in 1 hour, we have 3,600 seconds. So this is the same thing as saying 30 miles per 3,600 seconds over a matter of 1 second. Dividing both of these together, you now get 1 over 120 miles per second squared. In other words, this person is going 1/120th miles per second faster over every second. And that's pretty much all that's happening here. All in all, that's pretty much all there is to acceleration and velocity. It just comes down to just multiplying around. Change in velocity over change in time gets you acceleration. And intuitively, that also means that acceleration times the amount of time that was changed, or delta t, is going to get you change in velocity. And that also means that the change in velocity, or delta v times, not delta v, just the velocity times delta t is going to get you delta x, the distance and displacement vector. All right, that's going to be it for this video. There's acceleration and velocity. These are probably one of the most fundamental concepts in physics, and perhaps some of the most important as well. I mean, every force that you can think of, force essentially, at least according to Newton's laws of gravity and Newton's laws of motion and stuff, we defined it as force equals mass times acceleration, which is more or less the same thing as momentum over time. We'll get to that later in a future video. But essentially, mass times acceleration, any movement is based off of acceleration, is based off of force, and acceleration velocity is what you need to figure all that out. All right, thanks for watching. I hope you guys learned something new.